All right, so January 2022, question number 5. This says the cumulative frequency curve diagram below shows information about the distance d that each of 120 students walk to school on a particular day. All right, so we have a cumulative frequency curve. How many students walk at most 1 kilometer on that day? How many students walk at most? Now, 1 kilometer. So at most is an inequality term. It means less than or equal to. So to answer this question, what I want to know is to find out which student walk 1 kilometer. Now the distance is on the horizontal axis. So I just find one on that axis and draw up a line until it reaches the curve. Now, anywhere it reaches the curve, I'm going to draw a horizontal line across. All right, and I'm going to read that. So looking at this, this is, each of these is representing 2 students. Each minor division is representing 2 students. So this is 30, 32, 34, this is 36. So this is telling me that the 36th student walked 1 kilometer to school. Everybody above him walked more than 1 kilometer. Everybody below him walked less than 1 kilometer. So how many students walked at most 1 kilometer? So that's meaning 1 kilometer or less. The answer is 36 students. So the number of students less than or equal to 1 kilometer, the answer here is 36. 36 students altogether walked either 1 kilometer or less than 1 kilometer to school. So at most is an inequality term and it means less than or equal to. Next. We're asked the median. So the median is the distance the student in the middle walk. The median is the distance in the student in the middle walk. Now, there are 60 students altogether. So the student in the middle would be student number 60. So this is n over 2. N is 120. N over 2 would be 60. So I'll draw my line across. All right, my horizontal line. When it touches the curve, I draw a vertical line down. The answer down there, so is the median. All right, so this is the median. Let's see if we can read it. This is what distance in kilometers. Each of these little distance here is what? 0.05. It looks so. This is it's 2 centimeters to 0.5. So 0.5, that's 2 centimeters to 0.5. Divide this by 10. This is 0.05. Each of the division is 0.05. And every 2 of them is 0.1. So this is 1.1, 1.2, sorry, 1.1, 1.2. This is 1.3. So the median, this is 1.3. The median is 1.3 kilometers. So the median Q2 is equal to 1.3 kilometers. We need the lower quartile and we need the interquartile range. So in other words, we need Q1 and we need Q3 because the interquartile range is Q3 minus Q1. So the lower quartile Q1, we need to get Q1 and we also need to get Q3 because the interquartile range IQR is equal to Q3 minus Q1. All right, so let's get Q1, which is the lower quartile. Now, Q1 is the distance below which 1/4 of the students, sorry, Q1 is the value for the student who is 1/4 way up. Bear this in mind. This is N is 120. So up here is N is 120. A quarter N or N over 4 would be 30. So at 30, I'm going to come across. And we hit the curve, I stop. Then I draw a vertical line down. Whatever is that distance at the end of the vertical line, that is Q1. So this value here is Q1. And Q1 there looks like it is 0.9 kilometers. Q1 is 0.9 kilometers. How do I know that? Each of those small division is 0.05. So two of them is actually 0.1. So that Q1 is 0.9 kilometers. I also need Q3. Now Q3 is the value for the student that is 3/4 of the way up. 3/4 of 120 is 90. So 3/4 of N, which is 90. I draw my horizontal line across. And where it hit the curve, I stop. Then I draw my vertical line down. The value down there is Q3. So this value here is Q3. All right, and this looks like it is 1.55 kilometers. Because remember, each of the little division is 0.05. So it's 1.5 plus 0.05, which is 1.55. So to the other page, Q1 is 0.9 kilometers. IQR is Q3 minus Q1, which is equal to 1.55 minus 0.9. The IQR, which is the interquartile range, looks as if it is 0.65 kilometers. The IQR is 0.65 kilometers. Ladies, gentlemen, a student is chosen at random. What is the probability that the student walked for more than 1.5 kilometers to school that day? So what is the probability that a student walked more than 1.5 kilometers to school? So the first thing I want to do is find out who walked 1.5 kilometers. So 1.5, I'll go up. All right, then where it hit the curve, I stop and I go across. And what this is saying to me is that student number 82, student number 82, student number 82, he walked 1.5 kilometers to school. Everybody above him walked more than 1.5 kilometers. And what I want is the probability that someone walked more than 1.5 kilometers. So I need the people above him. The probability that the distance is greater than 1.5 kilometers is equal to 120 minus 82. Those are the students who are above the students over 120. Because remember, only those who are above him walk more than 1.5 kilometers. So this looks like 38 over 120. I normally like to write my probability as a decimal and as a fraction. So this is 38 divide by 120. And this is 0.32, 0.32, or 32%. There's a 32% chance if you select a student at random that that student would have walked more than 1.5 kilometers to school on that day. Let's turn the page. So where else this is going? All right. So examiner is really milking this question. It says complete the table below, and use the information to calculate an estimate of the mean distance walked by students, by the students on that day. All right, so we need to know how many students walk between 15 and 1.5 and 2 kilometers. Between 1.5 and 2 kilometers. So we need that. Between 1.5 and 2 kilometers. So we did 1.5 already, and 1.5 is student number 82. 2 kilometers. Two kilometers correspond to all right, let's see. It looks like it corresponds to 112. That's what it looks. Looks like it corresponds to 112. I could probably say more 113, but let's say it's 112 for the time being. All right, we'll know when we do the check which one is more correct. All right. So persons now who walk between 1.5 and 2 kilometers, this is 112 minus 82 minus 82. So this is saying 30 students. So in completing the table, this is 30 students. If this is 30 and the entire thing add up to 100, remember N is the sum of the frequency, and this is a total of 120 students. So if we want to find the missing one, we simply add up everything and take it away from 120. So it's 12 plus 24 plus 46 plus 30 plus 2. All right, from 120, this looks like this is 6. So it's 6 here. Now, to get the class midpoint, all right, the class midpoint normally goes up by a specific amount. It looks as if it's going up by 0.5. So if it's going up by 0.5, this should be 1.75. The class midpoint normally goes up by a specific amount. Now, fx is the frequency times the class midpoint. So this is 1.75 times 30, which is 52.5. So this is 52.5. And this is 2.25 times 6. This is 13.5. Now we're asked to get an estimate of the mean. And when you have group data, the mean X bar is equal to the sum of fx divided by n, where fx is an estimate. Fx is an estimate of the sum of all the values. So let's get the sum of fx. Let's add up the right column. This is 3 plus 18 plus 57.5 plus 52.5 plus 13.5 plus 5.5. So the sum of fx is 150. So this is 150 out of 120. So the mean 150 divided by 120. The mean or the average distance a student walked to school was 1.25 kilometer. An estimate of the mean is 1.25 kilometers.